Assignment 1, Jessica Ross. Welcome to the lesson plan for the topic of tessellation and linking that to mathematics in nature. The aim is to show students that there are mathematical related phenomena in nature. This particular lesson would be suitable for students in Stage 3 as it addresses the key learning outcomes of the Australian curriculum under the content description of measurement and geometry. The lesson has been broken down in parts. So firstly, you need to start off with a definition of tessellation, such as tessellation is a pattern which is formed when a shape repeats over and over, covering a plane without any gaps or overlaps. Next, explain to your students the shapes that you can use to create tessellation. Hopefully you've covered polygons. So just remind the students that you can only use regular polygons to create tessellations, and regular polygons are regular because all their sides and angles are equal. Show them examples of the tessellation individually. So you've got your square tessellation, your triangular tessellation, and your hexagonal tessellation. Now, once they've grasped the concept of regular tessellation, you can move on to semi-tessellation, explaining that two or more regular polygons together create a pattern of tessellation is known as semi-tessellation. So show them examples of this as well. You can then move on to the topic of linking that to mathematics in nature. One of the best examples of this is the structure that bees use to create their hive. Give the students an example of that structure, show them an example of a beehive, and then elaborate on that. So here's a good example. You can see quite clearly the tessellating pattern with the beehive. Next, put up a picture of 3 regular polygons and explain that of the 3, the hexagon has the smallest perimeter per given area. Explore the fact that this means that when the bees are constructing the hive, it takes less wax and the bees have less work to do than if the hive was creating using a square or triangular tessellation pattern. Show the students an image such as this, which illustrates that the tessellations are a built-up pattern creating shafts for the bees to fill. Explain that because the structure has no gaps, it is well supported, and each cell in the sheet of honeycomb can support up to 30 times its own weight. If you're able to provide students with a sample of honeycomb, that would be a great tactile activity where they could actually be able to feel the weight of the honeycomb, and that would further illustrate the strength of that structure. Give a few more examples of tessellation in nature, such as a tortoise shell, rock formations, or paving. And if there's access to any computers, ask students to search for images of tessellation in nature and share them with the class. The main activity for this topic, however, can be broken down into 2 parts. So firstly, create small groups and give the students 2 different shaped planes made from cardboard and a variety of coloured regular polygon shapes. Ask them to create a regular tessellation on one plane and a semi-tessellation pattern on the other plane. For the second activity, individually ask students to create a structure using polydrawn construction connection tiles. Once they have completed their structure, ask them to share that with the class and to explain which shapes they used and why. These activities meet the Australian curriculum requirement under ACMM G063, which is shape, make models of 3-dimensional objects, and describe key features. You can also link this back to the topic of symmetry which also has a nature aspect, as in the curriculum it asks for identifying symmetry in the environment. Always try to look for links to mathematics outside the classroom, as this will keep the students more engaged. Thank you.